Oh, let's see. We got people here. Looks like we got people here. Hey, Jim's here. Hey, Rilla, Boss Ned, Neo, Joey. Yes, right on time, as you know. Mm. Get some throat lubricant going there. Alrighty, better get some gloves. Can't handle this stuff literally without gloves. Okay. Hey, Harold, Sutter. Hey, Dreams. A laptop, PR. Okay, come on, get these 5-shot protection devices on. Hey, Teresa. Alrighty. Alright, let's see. Let's get straight into it. Make sure I've got my... Okay. These are the normal circuit boards for the ring lights. You've seen me work on them plenty of times before, and they are still the ones that we're making. But I wanted to do some experimentation and try a different design slightly. And so I made a broader version. So you can see this is the fat version, this is the non-fat version, the light version. Personally, I prefer full fat cream, so we'll go for full fat circuit board here. I need some more water. What have they been doing to you, Harold? What have they been messing up? One thing I noticed that they did on this is I intentionally left a... I didn't do a full cutout on this circle because I wanted to retain... why am I not being able to speak tonight? I wanted to retain the inner aluminium circle. They completely cut it out. So the reason why I wanted that is so that when I did the silk screening, it wouldn't get depressed in there. Oh well. Design-wise, they're both the same. Electronics and all that sort of stuff, it's all the same. The main differences are that if you line them up basically like this, there's obviously more area here for heat dissipation. The alignment of the screws is actually at a proper 120 degrees rather than this hodgepodge. And there's also a bit more of a lobe out the front here just to give a little bit more heat dissipation. This section here is this part that's going to get the hottest because it's got the furthest to go before the large area of the aluminium. Will it do anything? I don't know. That's why I'm trying it out. So we'll give it a shot. I just finished printing the ring for it. So it's... Hopefully it actually... hopefully it matches. A bit messy because I didn't dry the filament. So I'm just kind of curious with it. It seems like it's within a forced bodge distance. So yeah, we'll give it a whirl. Okay, so really what we have to do here is just stencil it up with solder paste. Stick it on the Lazy Susan. Loaded up the parts. Interesting, I see the ring hole. I made the ring hole a bit bigger too. Yeah. Alrighty. Let's get things underway. They don't mill the edge of the board as you draw it. Right, okay. Yeah. I haven't, like, in this particular case it's not a severe problem, but it is a problem in the sense that if I wanted that aluminium, then I didn't get it. And I did want the aluminium. Hey, Bodger. David H. Alright. Good old stencil. I do like that they're making these stencils cheaper for me to get now. It's like $7 or something. It was worth doing it. Let's see. This is the top. I should know because it's got all the marks on it. I'm just sort of blindly lining it up here. I really need to be wearing my glasses. Where's my glasses? There they are. can. Hey, Lexi, I just saw you there. I guess, Harold, the question you're going to face is, will it actually solve anything for you to go to another provider, or will you end up with the same sort of situation regardless? If I kind of hold this down, I might be able to paste it up, or dodgy job paste up. Let's give it a whirl. Yeah, let's see, I need my paste tools. Hey, Aussie Geek. Is this what I used last time? Got a whole stash of stencils. I'm not going to use this paste because it stinks. It stinks really badly when I'm reflowing it, and I'd rather not do that in here. No, the one I use is a red one, isn't it? Yeah. Need to find that one. Aha. What? Alright. My spudger squeegee thingy isn't there either. Where is it? A little bit frustrating when you can't find the tools you need. We'll get these things out anyway. Every single time I grab that LED strip. And where is my helper strip? Yeah, that's a little odd. Check my other container. Unfortunately, as you know, I've cleaned up the workshop, and subsequently a great number of things go disappearing or misplaced, or that sort of. But that squeegee unit isn't something I would normally misplace that much. You would have thought I should have prepared myself, but no, that'd be asking too much of me. I mean, you might have to end up using that other one. It's just a bit of a nuisance because you sort of develop a kind of an pardon me, you develop an edge on them. And kind of helps smooth the process over. Sorry about that. Yeah, I'm not rightly sure why I'm a bit choked up tonight, folks. sometimes when you're trying to do your streams, you just, yeah, you lose your voice for no apparent reason. Alright, so we're going to have to use this one here. I might just take this slip out because it's causing me a bit of grief. There we go. 18W. We don't prepare, no. We definitely don't prepare. I mean, you try a little bit, but there's always something that you've massively overlooked. Always. Right, this is really shonky town stuff. Taking me to a shonky town. Do you drink enough water in your day? Not always. I mean, I try, but not always. I mean, I don't often. Oh, guess what I just found? Just found it. Sort of get a feel for the. So that's a significantly more rigid metal compared to this. Which is better? Well, that's subjective, I suppose. A lot of work for just one pass of the stencil. Well, I don't lose my voice that often, that's what I'm talking about. It's like... And funnily enough, I have actually been drinking more water than usual today. Ooh, that's kind of... squeeze out the last bit. That's the end of that one. Oh, thank God I actually got that into the rubbish bin. Okay. And that is done. And a whole bunch of solder paste wasted. Perfect. There you go, Joey. There's some paste for you. You can... If I send that to you now, by the time it gets to the UK, it should be perfectly dry for you. Right. That just gets wiped off and thrown in the rubbish. Hey, Robert Cook. With JLC, if you order 4 identical boards in one order, they will be reviewed and edited by 4 different people. Right, yeah. Why not print a jig? Because this is a prototype. I print the jigs for the ones that are no longer prototypes. It's a lot of printing, I mean, for a one-off. Alright, I still don't know where the hell the guide is, though, that I normally use for holding down the tape. You know the one I'm talking about. It was a strip of circuit board that I had a bit of Tessa tape on that allowed me to hold the strip of LEDs. Anyway, that there. We'll just have to do it again. but I do wonder where the original is. It's over there in the thingy. It probably is, you know. It's always in the thingy. There we go. And someone didn't make it long enough. No, well. We can work with it even though it's not long enough. Yeah, but you see you get this flip over effect going every now and then. That's actually upside down. Okay, let's get the vacuum running. Come on, come on. There you go. Okay, I'm just going to verify this. Let's see. Yeah, I actually was wrong. Okay, so big blocks to the top, which means, oh my goodness. I have to flip this around because it's wrong. Holes down. Okay. Here we go. I'm just a little bit paranoid, so I keep double checking the underside of the chip LEDs, even though it should technically all be correct. Okay. Oh, that's right. The other thing I changed on this, now that I've just put this part down, was I changed the footprint for the controller. So it'll be interesting to see whether it has that tendency to pull itself across the board or not anymore. Because you remember that the last batch we did, we had to rework a bunch of them because of the fact that the pads were just too close to the ground center pad. and too long, and so it created a bit of an ambiguous situation in the reflow. It really doesn't matter that these are not perfectly aligned, because that's what we've got the reflow for. It also is not a problem, or it shouldn't be a problem, that this jack is recessed so far, because the diameter of the plastic housing around the jack is not greater than what the elevation is of that. And if it is, then it's a faulty cable, and we'll blame the cable instead. Hey Tom. Ach nee man. Okay. Dart is dart. Yeah, let's get the hot plate. We're only going to be using the small hot plate this time around. No point me firing up the great big chunky one. So I might just try to see if I can manually align that controller a little bit better. I feel like it's just a bit too much off there. Yep, see here we go. Hey Christos. It doesn't matter that it's hanging off the edge there a little bit, because that is just going to be, there's no paste there anyway. Let's see, we need an IEC cable, which we will steal back from the 3D printer because the 3D printer stole it from us. Wow. 3D printer just tried to rip my headphones out. Ugh. Okay, plug the cable in first. Then plug it into the power, so you don't accidentally kill yourself too many times. Okay, I'm not sure what temperature I've got this set for. 203. I'm just taking it down to 190 in this case. That's all we need. Oh, an extractor. Hey horse. Alright, now we wait. It won't take too long, don't worry. It's not like it's going through a reflow oven. Where are we up to? We're up to 60. Okay, it's taken a little while, but that's only because it's the first one. In the meantime, I'll look around for that missing support board. I will disconnect the vacuum pump. Okay, we're just past 100. Tom, no, it's actually to try and avoid having a heatsink at all. So the plan is, if I can get away without a heatsink, then that's good. And yes, that's quite hot. So essentially I'm using the extra area as the heatsink. And if it doesn't quite deliver the performance, then we can stick a little like 6mm heatsink rather than the 10mm units we've got. Okay, coming up to temperature now, so things should start jumping around. Shoot. There we go, the LEDs are off. Uh-huh. Interesting, the AVR isn't being pulled out. Don't touch it. Jack's fine. Yeah, it's interesting the AVR didn't get pulled across. Anyway, that's switched off now. So give it a chance to drop a little bit and then we'll draw it off. Hey Bodger, Mika is doing fine. She's actually she's getting surprisingly angry about her confinement, as you can imagine. Tomorrow will be day 5, so we're going to give her a little bit more freedom. Okay. Because they usually get to like day 3 and they're like, all right, we've been good, can you let us out now? It's like, sorry, no can do. Generally speaking, we usually keep it contained for a week for the girls. 3 to 4 days at least for the boys. Just to really give them a good chance to heal up, because the problem is if we let them out, they go straight to the trees, they go run up the trees and things like that. No, we can't have that. I'm just letting the extractor run a little bit to make sure it scrubs the air a bit more. Well, Rilla, this is an experiment and that's why we do it, so we can find out whether our ideas are going to be worthwhile or not. If I don't do the experiment, no one will ever know. And it doesn't bother me because I've already got the production units and they're fine. Okay. Let's see how bad this reflow went. Doo-ba-doo-ba-doo. Yeah, after Smudge came out of her tree like that, I don't think you'd be wanting to play the risk game anymore. Alright, so for the reflow side of things, that controller has sat in very nicely actually. Of course, part of that might have been simply due to the fact that I aligned it in the first place, but oh well. I don't know why the AVR decided it was going to stay there. I guess there wasn't enough surface tension pull to drag it back across, but that's okay. I'm fine with that. Usual ballage out on the LEDs, that's normal. I'm just going to double check they're all orientated correctly. So basically they should all have this notch here where the triangle is. Yep. Random hair, of course. I even added like an extra millimeter on the outside here. It seems like it's trivial, but it sometimes enough trivial things together can end up making a difference. Alright, okay, that all looks pretty good. Okay, now we're going to have to flash it. So if you don't like that kind of thing, just look away for a couple of minutes. Da, 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 da. Just gonna make sure I get my orientation. Oh no, that's right. I haven't got my little 3-pin header there. Where are you? This is extreme bodge level kind of work here. Let's see, ground. Okay, there. What? No such. Did you get unplugged? Three, 1, 2. Let's try that again. What? Three, 1, 2 should be UPDI01. It does exist. Cannot open. God damn it. Did someone in the Linux group decide that they weren't going to let me have permission to do this anymore? OS error, cannot open port, no such file or directory, and yet it... What? Have you died on me? You can't die on me. Oh, someone's bringing out the Arduino wars. Okay, so what's interesting here is that the port actually exists. Like I plug this in, and it comes up. So there we go. So here we go, schematics. Okay, it's disconnected right now. Now plug it in. Oh wow, it really doesn't. Who's FNAFerating with my stuff? And yet it did notice it right there. Okay, plug it in again. You gotta be kidding me. Try the other polarity. Same bollocks. And yet I'm showing power there. Alrighty, that's great. Now I've got to snake this cable back, try and find out where it goes, because naturally I haven't marked any of my cables. Okay. A bit crazy all the way over the top. What happened there? Alright, well it showed up there, so we'll try that. Still kind of weird. To be fair, that was plugged into a third-party port. What? So I'm gonna have to look at the version that I built myself and see if that changes anything. That is very strange. Alright. Actually, it's getting warm too. What the hell's going on there? Yeah, I've got to go find the program that I bodged myself. Oh boy. Fortunately, there's pretty much nothing to them. So, is this the one? Yeah, this is the bodge one I made myself. Okay, let's see if we can go to quad view. At least it'll give you an idea of what's happening. So I'm not sure what port this is going to come up as. It's also, okay, so this is 124 TTY USB naught. Okay, yeah. I can't remember which one's ground on this. Continuity mode. Speak to me. Great, neither of them. What the? Okay, so that's ground. I think. Why don't you mark the boards, Paul? Oh yeah, I can see it's ground now. It's got the it's got the thermal reliefs there. Let's mark it so we don't forget in the future. Nice big black marker. Nice red marker. Easy. Yeah, I'll have to have words with the designer for sure. But yeah, I am a little perplexed here as to what's going on with this port. So it shows up. Now I know what's going on, I think. How? What? this work before? What the? Okay, I think I know what's going on, but I don't understand how I've been programming them this whole time. Okay, so ground 5-volt UPDI. Okay, so that works there. Those are aligned. This one is not. I have to flip the cable for this one to work. What a freaking mess. No, it's not red for green. It's the UPDI and... Okay, that's interesting. Schematics. I just plugged that in, and it was trying to do it. It just failed because there wasn't a chip to talk to. So what if the problem is that it's getting shorted out or something? Okay. Yeah, something's shorting it out. That's the problem. Where the hell would it be shorted? Unless I did something wrong in the circuit board design. That's entirely possible. So... No? You got 692. That shouldn't matter. That's not... 693. It's not shorted. But I notice as soon as I connect it, it takes a dive. As soon as I put the UPDI on here, yeah, it goes noink and goes down. That's orientated correctly. I guess one thing I can do is check the resistance on a known working one. Be right back. Defect, minimally likely. I mean, unless it's anyway. Let's 5 to grounds, 560, 1650. Okay, so that's a different resistance there. Oh Jesus, was that a cat fight? Yes it was. I'll be right back. I think it was timber. Annoying little rats. Right, okay, so I've got a little bit of a difference in resistance on one polarity versus the other. I'm really actually not sure what to make of it. I could apply power and see what happens. And it can't be a bridge under here because, well, yeah, there's just no way that you're going to get a bridge left to right on that. I mean, could it be a bad AVR? Very unlikely. What do you reckon? Should I apply power to it? See what goes smoking? Because it's not a complicated circuit. Okay, we're going to apply power and keep our eye on that AVR. And we'll try to keep both those chips in view. What's the worst that can happen? Things could catch on fire. And I'm right here, and yeah, I might see fire. And I could panic. It's just really weird. Hey Christian, alright, so we're going to be pumping 24 volts into this one. Put the extractor on because I don't want to breathe anything. Well. Nothing's happening. Alright, it's time to make some measurements. Yeah, whatever. We do not have 5 volts. Oh wow, something's really shorting that sucker. Nothing's warm. Hey, mini tandem. Okay, so there's a short circuit going on in here somewhere, and I just don't know where it is. Not even sure. Yeah. Is it a bodgy design? It's kind of weird if it is, given that I simply stretched the board. That was it, as far as I know. Oh wow. Okay, these two sides are shorted. Which means... Oh god, yeah, I see what's happened. No, that makes no sense. I mean, Okay, what the... Oh, I know what's happened. Flip. Okay. No, it's not the AVR, it's the board. And I know why. Or at least I think I know why. Yeah. Let's get another one. We'll have a look at it closely. Oops. Okay. So basically we have 24 volts comes into here. Now I know this looks like it's going onto a ground on here, but it's not. This is actually just 24 volt sort of thing. But the problem is here. The problem is this. I don't know if you can see the difference between that there versus that there. Bit hard for me to... Okay, there you go. So this is the faulty one, this is the working one. And I know what's going on. The question is, do you know what's going on? Yeah, so basically the problem is that, see, this here is an isolated plated via, and I've just used it for drill holes. Now the reason why I typically use plated vias for drill holes is because, yeah, it's just nicer on the drills, and you don't get your circuit board flaking out and fibers and all that sort of stuff. So usually plating them is a good thing. But the trouble is, when I've plated this one, because this is an aluminium board, it's plated the inside too. So I'm basically screwed. Yeah, so basically these should have been isolated vias. Drill out, I don't know if I can drill out the plating because it basically just goes straight onto aluminium. What I really need is a isolation around the via. If I drill that, it's still going to be just touching. Wow, and to think I waited 3 freaking weeks for this. Good job, Paul, good job. You really effed that one up. You know, when I was doing it, something in my head said, you don't want to do that. Because, see, the problem I was running into is because I'm cutting it in so fine, the drill hole versus the Barlow, because I was cutting it in so fine, I thought, oh well, you know what, I'll make these vias part of the 24 volt supply, and then that way I don't, it doesn't produce a very narrow neck for the current to flow through. But yeah, so I wonder how thick that layer is. No, mini Tom, it's just, this is a prototype. This is me trying to do something, and welcome to why we do prototypes. So what I can try to do is see if I can, I just don't know if I can do it, but we'll give it a shot. Oh well, failure is a normal part of my life. So, okay, so we've got the copper layer here. Maybe if I can, if I had, yeah, if I had the right sort of drill, I could try and do it. But the trouble is, most high-speed drills, you know, with this, what is it, 30-degree taper, won't quite be enough. I really need more like a 10-degree taper. I'm just gonna see if I can actually slice the layer off. Hey, right, yeah, it's making errors with circuit boards is a very... Yeah, people often ask, why does it take you so many revisions? Like, why is this stupid, why is your stupid ring light up to version 7? I mean, how hard is it to make a ring light? And it's like, you go ahead. You try it, you do it. You don't realise how easy it is to have oversights and mistakes and things like that until you start doing this stuff for a living. I mean, there are definitely some people who excel at finding these issues prior to prior to production, and good for them. But for mere mortals, yeah. Ach, niemand. Okay, this is sort of what I'm trying to get done here, is cut it away from the actual veer itself, like that. Six or 7 revisions of the switch charger board. Yeah, I mean, it's stupid how many hiccups you're going to end up running into. And as I said, you face plant every time. You're like, how did I not notice that? I gotta admit, the separation, the isolation layer here is actually thicker than I anticipated, so I'm happy for that. Now, I'm not going to know if I have successfully cleared this or not until I've done all 3. I think I might switch to a new blade. But this is why we do prototypes. Okay, so that's one. I'm going to actually see if that layer is thicker than I expected, so I'm actually going to try to do... Ach, niemand. Hey Siri. Thank you, Siri. Yeah, I'm going to see if I can get a way of doing this. Sort of like basically cutting a chamfer off. Now, of course, this does mean that if I want to use... The screws I use for this are going to have to be nylon or something. Or I'm going to have to come up with something. Okay, that's that one done. Probably could have used a deburrer, to be honest, although I don't think my deburrer has a sufficiently narrow probe. Okay, let's see if we've got a short still. A little bit just on the edge here. There we go. It's a 1.7mm screw I use. Okay, we're still shorted. Actually a little confused as to where we would be shorted. Get out of here. Oh, come on. Yes, that's definitely aluminium alone there. Unless it's shorting on this corner here, like that. Okay, that shouldn't be there. Okay. Ah. I don't imagine the digging would be causing that. Hmm. And you can see that's cleared through. That's clear. This is a disaster. But again, it looks clear. There's no point me doing anything on the back side here because that's, yeah, it's just pure aluminium. I'd be very surprised if the DC jack was faulty. I mean, it's an idea. Might have to just pump many amps through it. Okay, I don't have a short there now. Maybe I did clear it. Maybe there was a little dagger. No. 0.2. What the flip? Ah. How's the aluminium not conducting? Oh boy, talk about making this a real pain in my backside and ruining everything for me. Yeah, I might have to go for DC injection just to see where it's popping up. It's very peculiar. Yes, I did have a DC jack issue in the past, but certainly not now. Yeah, it's still showing no voltage. .24 volts as soon as we disconnect. How positively annoying. Yeah, I'm kind of hoping maybe we can do a burn off with the current. Let's try a little more chamfering. Lift it up a bit. You can definitely, see the. Oh, damn it! Cut my tip. Broke my tip. You can definitely see the insulation layer in there. Well, one thing I can do as an alternative is I can take this resistor off, and that will let me know whether we've got a problem on this side or this side. Mind you, getting it off is not going to be easy. I think I'm going to have to go deal with the micro now. 0.3, yeah. The other problem is going to be if I inject power into this, it's going to be very hard to get it to heat up. The cable's going to heat up before the board does. Anyway, I'm just going to go deal with the micro and I'll be back. How disappointing. Right, micro. Miles, unfortunately. Oh, I'll put my microphone. Put the gloves on first. The software would not have picked it up because the software is assuming that the substrate is an isolation, is a FC4. Okay, so what we'll do is we'll start with a blank. We'll carve out the eyelets. And if the short goes away, then we know we've got something else. Not very pretty at all. Anyway. But yeah, having a conductive substrate is not really something that my simple old software handles. You know what would work well for this is if you had a large cutter that you use for wire wrap, not wire wrap, for proto boards. The boards where they've got just the strips of copper running in one direction with all the holes. Okay, see if we still got short. Yeah, no short there. Oh, that's actually because... Okay, so we need to compare this to ground. Yeah, okay, that's definitely shorted. Alright. I am wondering if it's actually this inner rim. Still seems pretty strange to me. Oops, cutting a little deep there, Paul, cutting a little deep. Just like my feelings right now with this board. I'm hurt. Hey Graham, no, bad designer, not boards. No, still flipping shorted. Ah, man, to think I waited 3 weeks for these. It could also be the outer edge now that I think about it. See, the problem is, so normally you leave, you can see here, this is the cut where it happens, and this is where your flood goes to. So you have this barrier between your copper flood and the actual cut. But I've kind of taken it a bit close here, like there, it's present there. You can see that there's the relief there, but then it vanishes around here. So we'll try cut that outside edge. Which I might be able to use the, what do you call it, the deburrer on that. Because good old deburrer. You're going to run, or you're not? Not the deburrer says, get stuffed. Alright. Come on, Devera, you can do it. So you do it yourself, you mongrel. Doesn't help that I'm left-handed either. Me and Deveras don't always get along because of the handedness. Okay. Just such a pain. What a waste of time. Okay, definitely in the inner ring section. Right, that's fine. Okay, I don't get it. Okay, the aluminium definitely is shorting to itself, right? So why isn't it doing it there? So we actually do have a problematic return somewhere. It's something else. Because if it was still shorted, see, I should be able to do this, and that should be registering as short. Yeah, I've got Dremels and whatever. Okay, so maybe it's not the board at all. Okay, see, I don't have a short actually between those layers, so we're actually looking in the wrong place. Alright, so... What the fire truck? So those two there, and they feed out, feed, and then feed back to there. Feed back to there. Where does this one go? You guys are... This is extraordinarily infuriating, I must say. Somehow I have got a... There it is. This is the problem. Okay, see this flood here? That's your ground. This flood, and see it merges in with that. That actually needs to be cut there. Let me see if that works. There might be another one on the other side. Okay. And we have silenced the short. That's what it is. It's an accidental merging. Wow. Okay, so there wasn't anything wrong with what I was doing in the first place. So this is the problem. So let's cut that. And see if we've got a short anymore. No more short. Far out. Okay, so it wasn't my eyelets after all. Oh, bloody hell. There we go. How did that even happen? Maybe I shouldn't even ask. hilariously, I probably have now, although to be fair, the eyelets would have been a problem, because as soon as I would have put a metal screw head in there and it touched the aluminium, it would have created the short. So that definitely was a problem anyway. So we kind of found both issues without having to do a second revision. A third revision, rather. Okay, so now the programmer might actually work. And I'll know because this green light, which you may not be able to see, will dip out if it's, yeah, it hasn't dipped out, so. And what do you know, programs. Flippin' heck. Crikey, mate. That was annoying. Okay, so it's, oh yeah. We've got one bad LED there. Okay, let's have a look at that. Why are you a bad LED? They're orientated correctly. And that's interesting because they're actually in sequence, in series. The only thing I can possibly think of is that it's bridged under there. That would be my guess. Yeah, I'd have to say it's probably bridged. Well, we can fix that too. Okay. Alright, we'll put that on the hot plate and we'll just lift that up. I can see there's a bit of excess push out there, so yeah, we'll fix that up. I don't think the LED is faulty. I think it's just got a connection of solder under it. Now you're probably wondering, why don't I just use the hot air? That's because the hot air is nearly useless on aluminium plate. Nearly useless hot air. How can you be nearly useless? Well, the UPDI thing was actually fine. It was the, what do you call it? It was the short that was causing the problem, so the UPDI is fine. I just plugged that cable back into where it was, and it will continue to work again. So which one was it? Oh yeah, I see now that one there. But yeah, the eyelets definitely have to have an isolation layer around them. Right. This one here on the corner. I could use non-metallic screws, but I'm going to put the eyelet, isolation in. I will probably throw the other boards away anyway. There's no point really keeping them. And the only reason why I ended up with 5 of them is because that's the minimum order quantity. Oh, I just realised it's Copaz. Hello, Copaz. $150. We've still got 30 to go. On 70, it's sort of getting to the point now where I could lift it. Maybe not. 180. Come on, man. Yeah, we're done. Miles, no, for the Barlow connection, yeah, we're still using nylons. But the nylons for the Barlow, these are the ones we're talking about, the ones that attach the adapter to the board. But yeah, the ones that touch the Barlow lens, they are already nylon. Really, it was my fault, not the manufacturer's. I was waiting for that to cool off still. So you want to get a 0.5. Ooh, hey, that's the wrong one. The only trouble with the 0.5 of the Barlow is just the massive working distance that it gives you also means you need a giraffe neck. I've got a 0.5 that I have for testing, or if I'm really going to be doing a lot of stuff that I need the lower magnification of, but I rarely, if ever, bring it out. Personally, I prefer not to have to use a Barlow at all, but and to be honest, with the narrow ring lights I can almost get away with that, because one of the big problems with the ring lights before, when you were not using a Barlow, is that you had to bring your hot air in at such a shallow angle. It was, necessitated the need for having angled tips on them, which I didn't care for myself. Never been a fan of the angled tips, unless they're more like the JBC ones where they actually curve them rather than just shove them in at 45. How am I going to fix this? Trying to think what I can do. Wonder if I can paint the top. I can paint the tops here with a bit of rubber compound. Yeah. Where is that stuff? Ah, there it is. No, you're not liquid anymore. Let's see. This is from 2 years ago. Tadic gave this to me. Let's see. Oh, you are still liquid. Oh, beautiful, beautiful. Oh, yeah, I love this stuff. Yeah, for reasons that I shouldn't. Anybody who uses this stuff knows why you love this stuff. And it's not for good reasons. That's actually probably enough. Oh, yeah. It's sort of like one of the few remaining things that haven't been banned. Come on. There we go. Yeah, Miles knows. Miles knows what it's all about. Yeah. I don't. It's this. Obviously, it's the solvent that they use, but geez, they make. Did they have to make it smell so good? Whew. Oh yeah, better put the extractor on. No, it's not like fiberglass resin. It's I really don't know what the solvent is. It is somewhat familiar to me, but I wouldn't be able to place it. I suppose if I just looked at the container, it would tell me what the solvent is. I mean, I suppose it could be sugary, but I do also know fiberglass resin smell. It's not that. Oh, whoops. Cancer and reproductive harm. Whoops. Let's see. Why does it not tell us what the solvent is? Flammable liquid and vapor, harmful or fatal if swallowed. Oh, wait, here we are. Yeah, MEK. That's what it is, yeah. Yes, MEK. I think I bring that out about once a year. We'll keep the extractor going. Okay, we've got our itty bitty screws. Wait, which one are these? Yeah, 1.7s. MEK also works very well for clearing brain cells, so it's probably not the best comparison. Okay, that's good. Okay, it looks like I'm going to have to use twos. That's interesting. The hole sizes I used here on the print were the same, at least in the specification of the CAD file, were the same as what I used for this. But they're not they're not agreeing with each other. Okay, that's fine. I have got plenty of other screws to use. When I order these sort of things, like if I'm thinking, oh, you know, I'm going to need a 2.0 or something like that, then what I'll do is I'll order a 2.0, 1.7, 2.2, 2.3. I'll basically just take a broad spectrum because I know that I'm probably going to be wrong. And at least if I'm wrong, I'll have something that's... Right, I should have some 2.0s. Here we go, these guys 2.0s? Oh no, you're the multi-comp one. And I went through a whole different set of grub screws. Yeah, I was just trying everything and anything. I could try use 2x10 nylon, but it's too weak for that sort of purpose. Okay, 2.3. Oh, this is 2x5. Okay, that's what I'm after. Yeah, blind budget. It's just, you get sick of going back more than once. It's like, stuff it. I'll just take a broad selection, and if I get it wrong, that's, just means I'm going to have other ones for future. But of course, the real trick is remembering that you did buy those next time you need them, rather than forgetting and repeating the process. I do prefer the 1.7s, I gotta admit. That one doesn't even want to sort of... That one's not even biting for some reason. Now it is. Nothing like about 20 kilos of extra pressure. Hey Riston, UK? Yes, it has been quite some time. How you been there? Okay, let's see if we got shorty shorts. 3K, that's definitely not shorty short. I think slicing software likes to change those hole size depending on width and not... Oh, okay. Yeah. Well, the thing is though that... I don't know, I'll double check it. But these ones came out great. And it's also the PET-G. It's the same everything. I'll just go back to my 3D software and FreeCAD and change it back. Ah, I forgot to put my inserts in. Alright. Is this them? 3x4, yep, okay. Every screw is a self-tapper if you... Yeah. Yep. I'm on board with that. I think that's perfectly acceptable. I did make enough of an adjustment on these ones so that the insert can actually rest in the hole. Whereas before I kind of had to force it. We don't need no special tool. We'll just prematurely... Oops. We'll just prematurely ruin our Hacko tips instead. Because if the plastic touches it, it does tend to... It's very acidic and it eats the plating on the tip. Yeah, Copaz, that's about what I'm doing, yeah. Still hot. I got the two different ones. These all came as a single bag of nylon screws, but there's two different types in there. There's a matte finish one that's slightly floppy, and there's a gloss one which is very hard. Or harder, I should say. Anyway, they both work. Okay. Alright, that's good enough. Alright, let's fit this thing. I think the MEK fumes have dissipated just enough. Miles, I've actually got one that was given to me, but I just didn't move. I stuck with the Hacko. If I'm going to change, I'll probably change to JBC or something like that. Okay. You're probably wondering what the hell's going on. Let's see. So I'm just fitting it. Okay, there we go. So that's running on minimum brightness now. Or is it? Yeah, there we go. Okay, so that's maximum. Let's get a microscope. Out of focus. Focus, you flip. Yep. Alright, so that is now running as full brightness. I'm kind of curious to see how hot it gets. Yeah, it's already warming up pretty good. So you may end up having to use a 6mm heatsink on it, and that's okay. Got to experiment. Can't just sit around and rest on your laurels or whatever you want to say. Blind budget, yeah, that's the concept. It's either do away with the heatsink or move to a smaller one. At this point, Miles, though, of course, unless something actually happens, I don't think I'll be changing anything too soon. Because I've got, let's see, I've got 1, 2, 3, 4, 5 different Hacko handles, about a dozen different tips. I've got 2 stations. Yeah, the investment's there, and there's no compelling reason yet for me to switch away from it. Yeah, if I was feeling like it wasn't delivering the goods for me, then yeah, sure. Fair enough. We've got a machine to fix here, so we might as well give it a whirl. Oh boy. I think the biggest problem with Hacko lately is just the fact that the prices are a little bit stupid. I think they got a little bit too I can't think of the word that I want, but you know, when Rossmann was promoting their gear a lot, even though he wasn't being paid or anything like that, you know, he was just saying, hey, yeah, it works for me. They must have got a hell of a lot of sales out of that. And yeah, anyway, so they kind of sort of thought, oh, we're untouchable. Okay, so 2141, this is probably going to be dead, unfortunately, based on the symptoms. Just scanning the code. Make sure that code's coming up. Okay. Alright. Now the reason why I think this is already dead is because they've reported that it's doing cycling of the power. And usually with 2141s, in fact most MacBooks for that matter, power cycling is indicative of the fact that they cannot find the SSD. This type of power cycling, like where it gets 20 volts and then it sort of runs for a little bit, then shuts down. Comes back up 20 volts, runs for a little bit, shuts down. And so what it's doing there is it's saying, okay, we're alive. Let's get started, you know, let's boot. And there's nothing to boot. And it's like, oh, we'll come back in 5 seconds. Yeah, it just keeps doing that. All right. There's a fair bit of dust, so that sort of indicates quickly that we are likely going to have SSD issues. So we'll disconnect the power. This doesn't look like it's been taken apart from the board perspective. It has been opened, but it hasn't actually been disassembled. So let's get this battery one out. Hey, Mr. Howe, good to see you. Yeah, the Chinese brands, like Axial, whatever they are, I mean, they're good. It's a bit like when Atten and Quick came to the market and pretty much saved or spawned a lot of the repair industry. I mean, you had Rossmann. Oh, geez, that's a helicopter. Not good. You had Rossmann encouraging people, and then when it came to the hot air, you had Quick step in. Like it was basically, well, you're going to pay $1,000 for a working Hacko, or you can pay $250 for one of the early Atom type ones, which weren't really that great. They were okay for iPhones, but they really struggled with the heavy thermal capacity of MacBooks. And then Quick showed up, and it was like, right, that's it. Everybody just ran to Quick because it had the power and the price. And then, of course, after that, Atom came to the market and said, we'll try too. And poor old Hacko is sitting there looking like a bunch of chumps with the, I think it was a Hacko 810 or something like that, but it was like $1,000 hot air station that was completely and utterly unusable. Do you have any full working M machines and you're looking to sell? Nope. No. I've got machines that I use as reference machines, but I don't actually have working ones. They're all iCloud lock jobs. Anyway, so what we're going to look for here is 2v5 NAND shorts. So, and okay, that one's good. Ooh, alright, this is interesting. What's PB Bus doing? No, that was a lie. Yeah, okay, interesting. How'd the Joey, we got it running. I've got it on the machine right now, like on the microscope, so we'll see how it goes. It turns out that the fault, there were two faults. One was certainly the eyelets are going to be a problem, so it's fine, I can fix that up. The second one was that I had inadvertently merged ground and 24 volt together, which is probably not a good idea on one of the flood fills. But at least now I know what I've got to deal with, and if I find that this helps well enough with the thermal, I may consider switching over to it. Or you know what, I've still got 50 odd of the other one, so I may just continue on with the original design anyway. This is really more of a idea tester board. Have you got your 24 volt power brick yet? Joey, have you got that 24 power brick yet? Because I know Bodger was looking, he sent you a link to one or two of them. It's kind of strange because for me 24 volts has always been around. It's like a de facto kind of voltage. So you basically go 12, 15, 18, 20, 24. So it was one of the sort of like the standard taps that you would get out of a transformer and stuff like that. And I've always seen it around. But it seems like it's less and less a case, and sort of 20 volts, thanks to USB-C, is kind of taking over. Unfortunately, for the sake of efficiency with the LED ring light, 24 is the required voltage. If I go with 20 volts, then I've got to drop the number of LEDs, which means I've got to probably use bigger LEDs, and diffusion may be a bit more of an issue. So anyway, it just sort of throws the balance out. I mean, 24 volt, it's readily available. If you look at a list of number of power packs being sold, like if you go to say like DigiKey or Mouse or whatever, and you list the number of available power packs for a particular voltage, then after 5 and 12, 24 volts is usually the next most common. You haven't purchased it yet? My goodness, man, I'll have to smack you round. think I'm going to have to, in future, that was a lesson for me, which is basically send the full package to people. At least the USB-C meter worked for you. Thank goodness for that, even though that was a bit of fun getting the software quite right for you. But on the upside, it was a learning experience, and we found a situation that other people probably would have run into sooner or later. Unfortunately, you ran into it first, and we were able to deal with it before too many other people did. So that was a bit of an advantageous outcome for us, for me. Not familiar with Pace. Nope. Yeah, no. Pace is kind of like a brand that was really good, or maybe really good, but it seems that the innovation seems to have been lost on a lot of them. I think that's the problem. A lot of these established brands, excluding JBC out of this, they sort of just didn't bother keeping up or changing prices. They just assumed that, here goes the voice again, must have just assumed that, oh no, we're going to be kept alive by the factories or the high-end rework businesses and things like that. But those high-end rework businesses have probably been having their lunches eaten by people like myself, just going around. It's like, oh, I'll do that cheaper, even though I don't really believe in that philosophy. Charge a fair price, but make sure you've got something to back up what you're doing rather than just purely price. Because sooner or later someone else is going to come along and they're going to beat you on price. And then you're going to be like, price isn't everything. It's good as a very first introductory situation, but don't rely on it. And more than anything, probably a good idea to bring your prices back up once you've established yourself. Otherwise, what happens is the market just starts expecting lower and lower prices, and eventually the market just sort of collapses. I mean, IT in general is... okay, what's going on here? The amount of hours you put into a lot of jobs, you really just don't get paid for your hours in IT. It's not a high return on personal experience or investment. Alrighty. Let's go looking around here with the new microscope light. Hey, Dratev. Okay, so we've got some, but that's PP bus there. So that's PP bus. So we're not worried about that one. Okay, that's not a good sign. And there was that, and there was that. This is very typical type of corrosion though, you expect to see. Okay, that I would say could be our killer, and if it is, we'll be very happy. Of course, we do have to clean up everything else, but yeah, if that is the culprit, this person's had a very lucky day. Assuming nothing else has been taken out in the process. And we're going to lose focus. That's not it. Okay, nothing wrong with that one. Alright, let's try these 2v5s. You guys are okay too. This is interesting. This is interesting. Now, of course, a few people might be wondering why didn't I power it up to verify what the customer had said. The problem is that with this particular type of fault, sometimes you are left with one shot. Like there may be one chance left for you to get the data off, and if you power it up, you basically toss that chance away. So when it comes to this particular model of machine, this and the A1990, you always take the board out and examine it first. So, okay, here's our problem. Notice how that is 23 ohms. It's not a short, but it's also not good. So it probably means one of these NANDs. If we're really lucky, it might actually be this here, but I sincerely doubt it. I have a feeling this one's already gone. Just bring up the board view and the schematic. Okay, this is not it. This is from earlier today. What do we want? The 1700. There we go. Okay, and this is by the NAND down here. Okay, alright, so that is on the 2v5 NAND rail. So what we're going to do is we're going to try and break that cap out, and hopefully, if miracles are going today, this might come back up high in resistance. Now it's a little weird because it is 20 ohms, and a lot of the time caps don't tend to fail quite so resistively, but it does, it's known to happen. I have had caps fail at like 30 to 50 ohms. It's very strange when it happens, but it does happen. Okay, I'm going to need to weigh the board down for what I'm about to do. Just trying to get the board into a position that suits me. Let's see, I'm going to use Bodger's awesome paperweight. So, yeah, so Bodger. Yeah, there you go, Bodger. We're going to use that. I might weigh it down enough. Or at least maybe stop it moving around quite as much. Bodger's like, that's not what it's meant for. It's supposed to hold beers and coffee. So send it back. To be fair, it probably could be a bit heavier for that. So thank you very much, Bodger. Okay, so we've got our Grim Reaper. This is only 230 air, so it's not hot. It's just hot enough that we can slice away this edge fill crap. Well, it is actually underfill, but yeah. But like I said, I'm almost certain this is going to be the NAND's already dead. To be fair, I don't know why it would be at this point, because the VREG section didn't look that bad. Okay. Alright, well, and then the next question, the big one, is what is the method of removal to be used here? I'm going to try see if my grabbies are going to grab it appropriately. Press down like a tooth. That wasn't very well done, I'm sorry. That was actually really badly done. Normally they should just shear off nicely, but I kind of pushed a little bit hard. Alright. Fingers crossed we get something much better than 32. Nah, 25. Okay, so it wasn't that. It's only really going up because it's cooling off. Yeah, it's not really. Okay. So at this point, when you've eliminated the likely culprits, you kind of want to bring out the hot air, the injection, but you do have to be careful. There's also that one there, I'm trying to remember that, I don't think that is part of it though. So we've got all these ones up here, little ones, more over here. So now, personally, when it comes to this model of machine, you kind of want to either see 0 ohms, like a really hard short, in which case it's probably capacitor, or you want to not see any damage at all. So we're going to put in Oh, thank you very much, Paul. Thank you very much to Paul Howe for contributing. You just sent through 100 on PayPal. Very, very generous, considering I just did a botch job. Thank you very much for that. Doing botch jobs is not what you're supposed to be. You're not supposed to support that, Paul, but thank you. Very much appreciated. Alright, let's rig up some wires. Like I said, I'm grievously disinclined to do this kind of thing, but sometimes you have to. And no, that's not a crack, it's a hair. Yeah, professional botch. Even I will admit that was a bit of a bad example. Good reason to make sure you don't apply any pressure towards the NAND. You always just sort of go sideways pressure. Okay, where's my little wires? So, fat ground wire. Sorry, I'm just trying to find my pre-made injection wires. Oh, can't seem to find my positive one. I'm almost certain I had it here. Ah, there you are. We're not going to get a lot of heat out of this. Like I said, 20 ohms. Well, I'll let you do the math. But if we go 1 volt into 20 ohms, you're not going to see a lot of current flow at that level. But we only need to see enough to be able to go, okay, look, we can see that's the NAND getting warm or whatever. Okay, I can tell you now that the heat on the light is getting pretty high, so it's definitely not going to cut the mustard, as it were, for a no heat sink solution. So we tried it, didn't quite pan out. That's fine. Next problem we've got is that this is all a bit warm. So put the cooking board there. My wife decided she didn't want this board anymore, so I said, I'll take that. It's nice and thick. It will shield the infrared camera from the underlying heat that's on the bench. Would it have been safe to use an iron on the side of that? The trouble is that, I mean, yeah, you could have easily used, well, the trouble with doing the heat on the side of the cap like that is that a lot of the time it doesn't come off. You probably will need the 2-iron technique, like either side, and even that brings its own issues because, you know, you can like pivot on that. Hot air, honestly, pickling it with leaded solder either side, then hot air, or physically removing it like that. I would prefer those two options rather than trying to slather it with lots of solder and then trying to, you know, saw it off kind of thing. Just never seems to work quite so well doing that method. I mean, other people may have better success. And I know some people say, hey, that's what you got to use your hot iron tweezers for. And it's like, no thanks. Most of the time, tweezers that are small enough to be able to fit into those gaps do not have enough heat transfer to be able to lift the caps out of those. The alternative is this is the alternative. If you want to use the iron method, is use hot air with like 200 or something like that, 220 maybe, to preheat it, and you got a chance then. I just realised I've got to actually set up the cabling. Okay, we're going to use 1 volt. Even though it's a 2.5 volt rail, we don't want to go there. And 1 amp. We're not going to see anywhere near 1 amp flow through this, from what I can estimate. We'll be lucky if we see 50 milliamps. Okay, it's rigged up. And has the software crashed? Of course the software has crashed. I wrote it. God damn it, every single time. If you're wondering what I'm cursing about, the trouble with this particular infrared camera is that it tends to always run out of battery when you don't need it to. So try it again. Alright, that's better. Okay, here we go. Power on. And yeah, so we're barely seeing 50 milliwatts. That's just not enough. I don't like that it's already centered on there. That would... Okay, so what we'll do is we'll push it up to 2 volts. That's not good. If it really is heating up where it's focused on there, that's not good. That would tend to indicate an internal board. The glowing you see over here is just a reflection. It's not actually... I might kill the main lights and see what it shows. Okay. Oh, yeah. Okay, what bothers me is that we're developing a bit of warmth around here, around the NAND, and that tends to tell me that the board itself might be shorted. Okay, I might have to cloak this. Find a suitable cloaking. On the upside, a shorted board is a good thing because it means that there is a chance for the person to get their data. Yeah, okay, so you can see how it's glowing around the NANDs and not actually in the NAND. So let me just shut the power off and see what happens. Now, hopefully it just sort of fades out. It does look like it's starting to fade out. And this is why you basically don't go in with a high voltage when you do an injection, because there is a chance that there are devices on there that are working, but if you go in with the high voltage, you're going to just ruin them. Particularly too, because at 20 odd ohms, 20 odd ohms, you could easily, I've seen some people go, oh, well, let's put 10 volts in there. And, but yeah, you can see it's distinctly fading out. So let's go. Let's put power back in. And yeah, you can see it's building up all through there. Yeah, we've had a few board shorts. So this one is definitely a board short. It seems to be central down here. I mean, I could be wrong. We'll just turn that off, flip the board over, and then see if it changes. Hey, Greg. Of course, the only way to really tell naturally is take the whole, take the NANDs off, and see if it's. Unfortunately, this is not really my domain. I don't do that process yet. Okay. Okay, so it seems to be focused right on that corner there. So we've got a very small amount of heat. But it's interesting that it's showing up everywhere. That's right on the corner of the NAND. So if we take away the night, so if you don't have it in the darkness, you can barely tell that that's where it's focused on. So it's around about right there. It seems to be the hot spot. We've had, with these ones at sort of the lower resistance, we have had a couple of recoveries, like have them sent off to another place. I'll put some IPA on and see where that's coming from. Agreeably, most of the time board shorts are somewhat lower in resistance. But Anyway, let's have a look. What in the literal... Okay, now I see why that's dead. How did we not see that originally? Yeah, well, that's definitely dead. My bad. That's been physically damaged. How did that happen? Alright, see now I've got to question myself, like, did I do that damage? But that's substantial. That's really substantial. How did I not see that? And I don't recall mishandling the board like that. That's certainly nowhere near where we did the extraction. Because we did the extraction other side up here, which is down here. It's nowhere near that. And we did it on a silicon pad, so no, that's definitely not us. How did I not see that though? I guess sometimes you get blinded, because I do remember testing these ones. That could almost be someone put a spudger through there trying to open up the case. Coaster painting. Okay, I need to go back and have a look at my video footage. Let's see, what is this job number? Yeah, 2156. 2156. 2156. No, it's definitely there. I can see it. Schematics. You can see that right there. You can see it's damaged. I don't know if you can see that. I don't know if I can enlarge this or not. But yeah, that's... It's terrifying what you don't see. But I can definitely see the black chink marks there. Like I said, when I look at it, that I can see that it's damaged, but at the same time, I really want to have a close up like this. But you can bet your boots that I don't go over that section while I'm under the microscope. I've forgotten how to go faster in this. You'd be surprised how many times this happens where you just don't... Oh, so close there, so close. Where you just don't seem to capture in detail that section that you're curious about. But yeah, like I said, you can see, well, I can see that there's a notch there and there's a notch there that should not be, and that matches very much with what you can see. Bring the light back on. Go to the over. Yeah, you can see it in effect there. That there is where the crack is. I'm just annoyed that I didn't actually capture it in high detail. There's enough there for me to know that I didn't do it, but like I said, it would be nice to have gotten it in higher detail. So yeah, I'd say someone busted that. Oh yeah, there we go. Yeah, it's very distinct there now. Oh, whoops, I can't see it. Yeah, you can see it's very distinct there. Yeah, I have to call this one. They're not going to be happy. Yeah, definitely that. Yeah. It is. You snagged and zoomed in. What you use flipping CSI technology, did you? Good on you. That was a good job. Well, that explains the unusual resistance readings then for me. Because like I said, 23 is not something that I normally see. It's usually 60, 6, 0. Typically, they're the values you expect to see with failed NANDs under normal circumstances. 60 is a partial failure. 6 is definitely a failure. What is this over here too? That's interesting. It's a bit of evidence. Some sort of candy-coloured whatever. But yeah, I would say someone was opening this up. It may have had another failure. Someone opened this up and smashed it. Because that really does look like... I mean, I could be wrong, but it really does look more like a spudger. Poof, slip and smash. Well, 20 ohms seems to be someone did bad. So there you go. It looks like I was wrong about the NAND. I mean, I was wrong about the board. But I was also, that was an unusual one. That sucks. Particularly too that the customer, well, the business that sent it to me says the customer's very adamant about getting their data. And I'm like, well, then they're definitely not getting their data now, even if they wanted. No matter how much they pay, they're not going to get that data, I don't think. Because once you lose one of those NANDs due to the way that the data is spread and encrypted and all that sort of stuff, you just don't get it back. It's like having a RAID 1 configuration, or is it a RAID 0 configuration, and you lose one of your drives. Well, I only wish I'd seen that originally, because then I could have just closed it up straight away and saved us all a lot of drama. Well, that sucks. Could be just that the previous opener used a metal spudger and shorted together PV5. Well, 2v5, I don't know. Do you think a short shouldn't cause it to blow like that? That really does look like physical damage as opposed to exploding damage. Like, it feels like impact. I mean, I could be wrong. I mean, I've already been wrong once. I think the evidence for it being a physical impact is that we've got damage here on the cap. Yeah, that's someone's put a spudger in for sure. That's impact. There's no two ways about it. That's impact. Yeah, but how the hell they did it, I don't know, but that's definitely impact, because it's cleaved away that cap. Definitely a whoopsie. And I thought this was a crack, but it's not. That's a scouring. That's a drag mark. Something's come across there from the top and gouged out. Yeah. And then they've sort of went, oh crap, tried to compensate, and then just, yeah, I'd say a metal spudger or something. They didn't quite make it over here, but they definitely chunked the living hell out of this one. I didn't get it though. I don't know how it happened, to be honest, fully, because none of this stuff is damaged. So no, which angle did they come in at? Did they come in at this angle and then arc it this way? Yeah, it's confusing. Joe, what you're talking about, the microscope? The image quality? Yeah, the funny thing is I don't get to appreciate if it is looking good. I don't get to appreciate it because my screens suck. When I look at the screen, like I would like to get a proper monitoring monitor, like for broadcast monitoring. Because when I look at this, it looks dim and yucky. So, yeah, yucky. Let's have a look at the case. Let's see if there are any clues in there. Oh, yeah, there's a big fat clue here. Or is it? No, that's definitely raised. The battery's been attacked. Dunk. This. Alright, so this here is, we're in this area that we're looking at. Okay, now that's just goop. We've got a V scratch. That could be actually just, what do you call it? Markings from the factory. Is that... It's too low. That's an external impact. That's not the cause. Yeah, I'm really not seeing any other signs here. Maybe they're using a Grim Reaper. Really looks like it was something more intense than a Grim Reaper to me. But yeah, maybe. Its question is, I don't know whether they did it while they were trying to get the case off. Like this. Interestingly enough, this case was taped on, so I didn't even have to use a spudger to get it off. I am struggling with this in terms of how it happened. I mean, I'm glad I know it wasn't me. But it almost feels like maybe it happened outside of the case, but then these weren't really tampered with. It's confusing. It's very confusing. I think it's just a metal spudger pushed in too deep or popping the cover off. It's quite possible, yeah. Whatever it was fatal. So it's the end of that for them. Alright, it's getting late, so it's actually time for me to go and leave you all. So it's been a bit of a not quite so successful night tonight. And this person's going to be very upset. Yeah. That's it right there. Yeah, they would have had to have, I don't know, went in too deep and maybe rotated. What's your theory? Well, you already hear what Graham's is. Yeah. Anyway, frustrating Monday. Yep. So I am going to leave it at that. Thank you everybody for being here. Certainly, at least we discovered a few things and bad designs, mine. And yeah, it looks like I'm not going to worry about doing any more of those extra large heat sinks on the aluminium boards on there. The only thing that I'm carrying across as a new design from that ring light is the improved footprint for the controller for the LEDs, but that will come in after I've finished using up all the existing ones. So really, we'll be continuing on like this. I will, however, be applying more and more now this extra thin heat transfer tape. This is 0.15, whereas the previous ones have been 0.3 or so. So the 0.15 does seem to do a little bit better. If you already have yourself one of these, try apply the 0.15 heat transfer tape. You might find it works better. But to be honest, I find even in its standard form, I can leave my finger on that aluminium right there, even at maximum brightness, and it's no problem to me. Either that or I'm well calloused. Hey, sweetie. Oh, yes, please. We've got malt. Oh, can you hand me that? Sorry. People have been wondering. Everyone thinks I'm using Horlicks, but I'm telling them I'm not. See? Not Horlicks. It's Saunders malt extract. There you go. Anyway, I'm out of here. I'm going to go enjoy this. All have a good time. I'll see you later. Here you go, sweetie. Yeah. You're right.